All right. So my name is Ubaid Faruqi, or as some people call me, Obed Faruqi, uh, and I'm part of the interoperability support team, also known open specification support team, also loosely sometimes called protocol team. And I will be presenting Windows Hello Internals, a protocol perspective. So hopefully, let me do a check here. How many of you know what Windows Hello is? Okay, so it appears that everyone pretty much. So I don't think I need to do a demo of Windows Hello for you guys. The purpose of my presentation is to actually uh, show you, or actually discuss and show you the protocol flow that happens during authentication and the provisioning of Windows Hello. Okay, so let's get a start on that. uh, I actually do not like to do it this way. No, that's fine. I actually just like to do it this way because I have more control this way. So what is Windows Hello? It is a new way of logging into your device. The thing is that the experience, the mechanics of logging into your computer is different. But that is not the only thing that is different about Windows Hello, and we'll look what's that. It uses PIN or gesture instead of password. That is the key. You don't have to enter your password, but you can enter something similar called a PIN, personal identification number, which could be as small as four numbers. Okay, so sometimes people wonder why it is more secure than the password, and you will learn through this presentation why it is more secure. Although PIN seems to be less secure than password. Uh, when PIN was used, just the PIN, it used to be called Microsoft Passport. Uh, and then later on, we added gesture in addition to PIN to Passport and started calling it Windows Hello. So before Windows Hello, you may have heard about Microsoft Passport. That was just the PIN login. Uh, the reason it is different from the password based login is that it uses asymmetric asymmetric keys for authentication. How many people here know what PKI is or know anything about asymmetric keys? Okay, pretty good. I think I don't need to go into detail on that. uh, when you use your PIN or gesture, it will just unlock your computer. The user experience is actually even better than the password, because typically if you even use PIN, the PIN is only numeric and you don't have to type 15 character long passwords, which we are kind of required in some of the security situations. uh, it is a two-factor authentication. It means that PIN that you have will only work on your particular device. So if somebody even knows that PIN and he goes and tries on another computer as you, it is not going to work. It uses TPM for storing private keys. So this is an important thing. If even if your machine gets hacked, nobody can get the private key, because the private key is in the TPM or trusted platform module. How many people know what TPM is? Okay, good. Um, so my audience probably know the whole presentation already, right? Okay. So in a enterprise environment, or I will also tell you about a non-enterprise environment, but in an enterprise environment, when you log in, you are authenticated against a domain controller, right? That's how the enterprise authentication works. And in this case, the domain controllers only have public keys. So the asymmetric keys are two keys, private and public. Private stays in your TPM on your machine. The public key is in your domain controller's user object. Okay, people who are familiar with the Active Directory know that there are, for every user there is a user object in Active Directory, and the user object has attributes of the user, and one of the attribute is called MSDS key material, which is kind of a new object introduced for taking care of this. Available only Windows Server 2016, by the way. No, obviously I asked for it. Okay, so Windows Hello can be in the corporate environment in 3 different configurations. You can have everything on the cloud, right? So your Active Directory, everything is stored in the cloud, and your computer authenticates against the cloud. That's one way of deploying Windows Hello. The other one is called hybrid. This is where you have an on-premises DC that you authenticate against, but in order to use Windows Hello, you will have to use multi-factor authentication, and that's where Azure comes in, the cloud comes in. And so what happens that the provisioning and the multi-factor authentication all takes place in Azure, and then your on-premises domain controller replicates with Azure, so it has your public key, and then later on you can authenticate against your domain controller. You don't have to authenticate against Azure Active Directory. And then there is a third one, which is the newest of all. It's all provisioning happens on the premises. Basically, you use the on-premises domain controller, and everything happens on premises except one little piece, which is multi-factor authentication. You need a little bit help from Azure to do the multi-factor authentication, but that's a one-time step. Once you are provisioned and done, your authentication will happen in your local on-premises domain controller. This is already announced, but the actual bits like the software will be delivered through an update pretty soon. Okay, so for all those deployment types that I showed in the previous slide, you can have Windows Hello in 2 modes. One is called key trust, and one is called the certificate trust. A certificate trust is the more familiar one. Everybody knows how many people know about a smart card authentication. So that's exactly what certificate trust is. But in this case, the certificate is not on a smart card, but the mechanics and everything else of logging in is the same. Okay. In this case, the certificate will live on your TPM. Okay. It will not be in your smart card. Basically, you won't have to insert your smart card to do authentication. The key trust is the new one, new in 2016, and this is the interesting one because it actually does not require you to have a certification authority. You do not have to have user certificates. Okay, you do not need to have user certificate, which means that we do not. So how many people know what a certificate is? Okay, I will just still explain it. A certificate is your primary key in a asymmetric key or public key infrastructure. There are 2 keys, private key and public key. Public key is in your certificate, which you can freely distribute throughout the world. You can give it to anyone. Public key plus there are some other information, who issued, what's the purpose of the certificate, stuff like that. That's part of the certificate. In the key trust, you still have a key pair, a private key and a public key, but you have just the public key. It is not wrapped around into a certificate. Okay, So the thing that you need to understand, that certificate has an expiration date. This public key does not have an expiration date. So this is pretty much same as certificate, but client and user certificates are not needed for the reason that we actually do not have the certificate. We just have two keys, one private sitting in the TPM, one public shared with the rest of the world. But we still need a certification authority in this scenario at the time for when the provisioning is happening. You want to know the server you are talking to is actually a legit valid server. And for that, you need to have a certificate for the server, but just that for the server. Okay, I have the tendency to just keep talking and people get sleepy, so I would encourage you guys to please participate. Ask me a question, even if it's any kind of question.
I obeyed.
Yes, sir.
So for hardware requirements, you need the TPM. Are there any other hardware requirements?
For gestures, there are certain kind of cameras that you need to have. For the fingerprints, you need to have a fingerprint reader. Some of, like my older work laptop does not support Windows Hello because the camera is just not up to snuff to do the gesture. Because
that's exactly why I asked the question, because I have my desktop and my laptop both say the hardware doesn't support Windows Hello.
Exactly. By the way, what happens behind the scenes is that it takes a picture of you and then it somehow serializes that picture into bits and bytes, as we know, and then generates a hash out of it. And every time the camera looks at you, that process goes on all over again, and it generates a hash, and that hash is used to unlock your TPM, which has something called containers. Okay, and there are two kind of containers in the TPM. One is for your personal keys, and one is for your corporate keys or enterprise keys. But the hash is just one. Previously there was a problem that you need to have separate pin for corporate or other pin for personal. In this latest release, we have removed that problem as well. Okay, so far we are talking about the what Windows Hello is and how it is done. Let's look at the protocol flow here. So the key trust protocol happens regardless you want key trust or certificate trust. The reason is that you need to generate the key pair even when you want a certificate. Okay, so anybody can read what is written in the slide, or should I zoom it even further? All right, so here is a protocol flow for key trust, and this is provisioning flow, not the authentication flow. There are two parts of Windows Hello. You have to first provision it. It needs to take your picture and digitize it and generate a hash, and the same way it also needs to generate key pair and stuff like that. So here is what happens. You log into your Windows 10 computer, and your corporate has pushed a policy through group policy that this computer needs to use Windows Hello. That policy has a link for your ADFS server. Okay, so your computer will, without your permission, actually just log into that and present you a web page, which is a full screen experience. You won't have to open the browser, but it's basically a web page. So the first line, which says that MFA authentication, the communication that's going on between ADFS 2016 key registration component and Windows 10 is nothing but some HTTP hypertext HTML data is sent to your Windows 10 computer. It displays a screen to you, and it asks you for your corporate credentials, the old username and password credentials. You will have to enter that. Once you enter that, it will do multi-factor authentication, meaning it will give you a phone call or some other way to make sure this is you, because anybody else who has your password can do that. So we do two-factor authentication. I would like to emphasize this again. In this room, if anyone who actually is an implementer of ADFS, as far as Windows 10 computer is concerned, it is talking to ADFS. The multi-factor authentication is happening at the back end of that. And after multi-factor authentication happens, what ADFS does, issues you a claim. Okay, if you are an implementer and you do not believe in multi-factor authentication, you can implement your ADFS such that you will just issue a claim without going through the multi-factor authentication. Microsoft strongly recommend that you do not, actually very strongly recommend that you do not do that. And in our implementation, it is not possible to do it without multi-factor authentication. Okay, so what happens that in ADFS, the ADFS 2016, just to do the multi-factor authentication, we actually install something called an adapter. Okay, that adapter and the MFA server comes from Azure. Okay, it is not part of the Windows 2016 ADFS server. Okay, again, as I can see, I'm just keep talking. Any questions? How does the MFA server know what to do? Okay, yeah, so obviously there is a communication. The adapter that MFA server has got installed in ADFS. ADFS has a API, so it uses the API to just make a call on the API, and the adapter and the MFA server takes care of the rest.
The MFA server needs to have the information to do the second factor authentication. I mean,
Yes.
it is to know my phone number or something.
It is connected to the internet, and it actually talks to Azure to get that accomplished. In case of phone authentication, there is I think there is some other legacy software, but it is basically implementation detail from this point onward. In our solution, it actually talks to Azure to do the multi-factor authentication. So the multi-factor authentication is successful. MFA server will inform ADFS. The authentication is successful, and an MFA claim, multi-factor authentication claim, will be issued to Windows 10. Okay, after that, you will create a PIN. User will be asked to create a PIN, and then when PIN is created, a key pair is generated in the TPM. Okay, if the device does not, going back to what Jeff asked, if your computer does not have TPM, for now we have a solution where the keys can be stored in the software, but that is only because not every computer currently comes with a TPM. But the ideal situation is that it should be in the TPM so that it's very secure. So keys are created, and then now the client has both public and private key. In order for the authentication to be successful at the later stages, that key needs to be in Active Directory, right? So that you can authenticate against that. And the key registration is the part that registers your key with Active Directory. But if you will notice that the line going from Windows 10 to ADFS, the reason is that when the key registration request goes, it also goes with the claim token that we got in the second step there. So it checks the claim. If it is coming from the proper computer, it will send an LDAP request to domain controller to write the key in the user object. Okay, the key will be written, a success will be returned to ADFS, and a success will be returned to Windows 10, and that will finish the key trust provisioning. Okay. Now let's see how certificate provisioning works. I mentioned that certificate and key trust are very similar in the sense that both use public and private key. So all the steps that we did in the previous slide will happen, but if we are going to do certificate trust, Windows 10 will now send a certificate request to ADFS, a component of ADFS called certificate registry registration agent. So previous component that was dealing with keys was key registration. This is certificate registration. Again, with the claim that we got in the previous slide, if the claim checks out fine, we will also send an LDAP request to get the public key that we have already saved in AD. Okay, we will get the public key, and then we will use that public key to send to the certification authority so that we can get a certificate, because public key is nothing but a certificate is nothing but a public key wrapped around with a lot of other information. Okay, so the certificate is signed by certification agent, so certificate authority knows that it is coming from a reliable source. Okay, because certification authority may not know, does not know your Windows 10, but it knows that certificate registration authority or agent. A certificate will be issued, certificate will be sent back to the Windows 10. So now we have the certification trust provisioning done. The next step will obviously be how do you authenticate once you have done all that. So any questions so far? Too dry? Go ahead. Okay, I did not hear the whole question actually.
When would you recommend using key trust versus certificate trust?
This is really a solution. This is a decision that is up to the organization or the enterprise that is rolling it out. But the factors to consider is that in order for the certificate trust to work, you need to have PKI in place. Okay, whereas for key trust you do not need PKI. That's one. The second thing is that the requirement for the domain controllers level for certificate trust are actually much lower. You can do it in the 2012 R2. So if you are not willing to upgrade to the next version of the Active Directory, then certificate trust is, The third thing is that key trust is a new thing. A lot of IT people are more comfortable using certificates because it's familiar. They know how to work, how it works. So those are the factors. But I think one of the biggest one would be, if I don't want to deploy Windows Server 2016 right now, then certificate trust is the obvious choice. All right, so the document that we updated to
maybe it's a question that could wait until the end, but I would actually want to know how all this is going to look like with companies moving toward virtual desktops. So no real TPM, no hardware TPM. Where's the key gonna reside?
Okay, so let me just rephrase how I understand your question. You are saying that how it would look like when the companies move to the virtual desktops. When you say virtual desktop, you mean people will not have a computer running Windows, but basically just using virtual machines that are running on a server? To be honest, I am not the right person to answer that question. I do not know at this point. So if I don't know, maybe Diane can give you some pointers as to where we can direct this question, because I'm sorry. Okay, So the documents that you wanna, yeah, just tell it because other people will also want to listen to.
Yeah. Well, this is a solution for Windows clients. Okay. And even then, if you don't have a TPM, you're at least expected to have TPM virtualization. So the newer hardware and the newer builds have TPM virtualization implementation, which is going to serve in the absence of real TPM chips.
Follow-up question is then, of course, people are not having their own computer, and this key is in this one particular TPM. So if you have it virtualized, they're logging on to any desktop, could be any in this whole pool of virtualized desktops. So there's not which virtualized TPM is going to be accessed. I don't know what that looks like.
I guess that. Yeah, I do not know the answer for that. I guess someone from Hello Team probably would be able to answer that accurately.
So there are several documents which we updated for this upcoming patch that will be released soon. That will give you the functionality, and if you are an implementer, to implement in your solutions like ADFS solution or the directory server, the domain controller that you need to support Windows Hello. The document that was updated for key provisioning protocol, it was updated to show you what happens when you register a key. And the document OAPX, PXBC, and OIDC, these were updated to include the scenarios where you register the certificate. Because as you see in the previous slide, let me actually show you the previous slide. Okay, that's interesting. I cannot go back. Okay, yeah, that's what I'm doing wrong. Okay, so let's start from here. This area here, key registration. Is there a pointer in this thing? Okay. Yeah, laser pointer. No, it's here. It's here. Okay. Yeah. So you see this area, this key registration step here. This is actually described in MSKPP document. Okay. And in the next slide, this step here, this one, since ADFS actually communicates over HTTP and it uses OAuth and OpenID, OAuth for authorization and OpenID Connect for authentication. So those documents that I showed you in the next slide, these are about OAuth and OpenID. These are updated to show you these three documents here. This 1, 2, 3 these three documents are there to update that aspect of it if you are an implementer implementing ADFS. Okay, so these are the ones that are updated in the current release. So if you go on MSDN, open specification documentation, and open any of these documents, the first page will show you how many people know that you can actually see the diff of this release from the previous one on the web page. Okay, so I guess it's a good idea I show you how we do that. Okay, I am not connected. That is wonderful. Let's see. Cannot connect to this network. All right, I'm good. Okay, you go to the documentation tab. Again, I cannot connect. I don't know why. All right. Any document that you remember in that list, MSKPP, that's the easiest one, right? Let's find that one. It takes some time to build that list and show you. There are like hundreds of documents here. So when you go, so if you guys are not familiar with this page, you can always go to msdn.microsoft.com/documentation. Instead of typing the document name in your favorite search engine, I suppose that is Bing, you can come here and look for documents, and the one that I am looking for right now, uh, it's slightly more work, but it is actually, the rewards are great because you get to see lot more stuff than just the document that you are interested in. Okay, so KPP should be, if my English alphabet is still correct, would be this. Okay, all right, so what I want to point out to you is this thing here called diff. Okay, you click on this diff and see what happens. So this is in PDF format. It's not in the Word format where you can say show me to the first change or next change, but it is still very useful. You just have to look for the red content. So for example, in this page you will see that this document has this change significantly. It has some new major content in it. And then as far as the real meat of the change, you have to look here, and then you will see that a lot of things updated in the it has been updated in this document. And for this particular one, remember, when the next release of this document come after this release, then the diff will be between this release and the next release. Okay, so this is a good time to go and study the changes because they will not be available there forever. The diff is only till one release. Is that true? Okay. Okay, yeah, you're right. I think there is stuff here that you're talking about. All right. Awesome. That's a great feature. I did not know it, and I work with these documents day and night. Okay, so this is a very handy feature if you want to see, because it's very targeted and makes your job easier. So we were talking about the diff, that you can find what changes are made for Windows Hello. And these are the documents, and you will have these slides, so you can reference that what documents were modified. Yes, sir.
What is different in the document, especially the OAuth and OpenID that Microsoft extended, because those are standards.
Yes.
OAuth and OpenID Connect, they are all standard. What did we do differently to enable Windows Hello?
So I do not know all of the changes, but KPP. What did we do in KPP? Only I actually read all of them. Some of them did not make sense to me because I don't know the whole big picture. But the one that really made sense to me when I go and talk to some of the designers. So the OpenID does not have, they added something called capability in there. The changes were made in the OAuth to accommodate the certificate registration. Okay, but I do not know exactly the details, what is exactly added, but yeah, these are the extensions. For the key registration is the same way. We actually do, when we register the key, this protocol is actually not new, but it has been augmented to take care of this particular scenario. You have a question, sir? Okay, it looked like you raised your hand. The writing of the public key to AD is simple. So let me go from the beginning. MFA authentication. If you look at my slide, the first thing that happens is that your Windows client communicates with ADFS key registration. That is just basically a web page. It's just HTML. Okay, so HTTP is used between Windows 10 client and ADFS 2016 for that purpose. ADFS on the backend talks to using the adapter to the MFA server, does the authentication, and then sends back the claim. For key registration, the document to consult is MSKPP. Okay, if you want to see the details of key registration that happens between Windows 10 and ADFS after the keys are generated, you can go back to my slide, and I can go back to my slide 2 to show you which step I'm talking about. The title of the step is the same, key registration, and that is actually described in document MSKPP. Writing public key to AD, this is LDAP, old stuff, nothing new here. Certification request from Windows 10 to ADFS 2016. This is actually where the major changes has happened, because what happens that generally in case of PKI, you just directly send a request to a web server authority which is configured for your organization, and then you will receive a certificate. But in this case, it is going to ADFS, where the authentication is in this case, the authentication that we are using is OpenConnect, which runs on top of OAuth. So that's why those documents about OAuth and OpenID Connect are modified, actually augmented, I should say. All right, so now you are provisioned, everything is fine. What happens when you log in the next time? Because now you are not using your password. In some cases, you can still use the password. It really depends upon your administrator or how they want to do it. But you log in using your PIN, for example, or your gesture. What happens? So what happens depends upon what kind of deployment you have. If you have the hybrid deployment, if you have, actually let me mention, the reason I did not mention the first one is because that does not involve Kerberos. But the first type of authentication that will happen, which is only the Azure AD deployment, you OAuth and OpenID Connect will be used to authenticate you. In the case which this presentation is all about, which is using your on-prem DC, if you have a hybrid deployment, either one can be used, because what happens that when you provision your public key in Azure AD, there is something called Azure Connect. Okay, so your key is replicated to your on-prem domain controller. Now your domain controller can be used for authentication as well, and if your on-premise domain controller is used for authentication, Kerberos is used. Okay, and the Kerberos documentation for actually PKInit documentation for Kerberos has a new section added just to describe how the key trust authentication will happen, because the certificate authentication is old thing. Smart cards has been doing it for years. People are familiar with that, and that content is already present in the documentation. So for hybrid deployment, Kerberos will be used if you have on-premises, if your on-premises domain controller is used for authentication, And if, of course, the Azure is always available, because there is times when on-premise is not available, but Azure, being on the internet, should be available all the time. If you have the on-premise deployment, for which I actually am presenting this, your authentication protocol would be Kerberos. So there will be no way you will be using NTLM authentication in case of Windows Hello. Okay. And the Kerberos protocol uses public key init, PK init, which we describe in the documents PKCA, MS-PKCA, and I mentioned this document in the next slide, which we create a new attribute in the user object called MSDS key material, which holds your primary key. When your AS request will go to the domain controller, your AS request in your pre-authentication data will have your public key, and domain controller will compare that public key with the public key that has its in record, and if they match, then authentication will go on. You will be issued a ticket, and life will go on as normal from that point. Any questions? So the documentation that are updated for yes, sir.
Since there is no password, and assume there is no certificate, we are not using the certificate case. How does the PK init work?
Okay, so I think the structure in your pre-authentication data, it is called PAPK. I forgot the whole name, but it is in the documentation. Actually carries, instead of your certificate, it just carries your public key, and that public key gets compared to what the Active Directory domain controller has in there. If you have a certificate, the mapping, user mapping, is done differently. But if you have just the public key, we just have only one way of mapping the user to the proper object, and that is comparing the public key in the MSDS key material attribute of the user. So documents updated for authentication, MS-PKCA, public key cryptography for initial authentication in Kerberos protocol. This document actually updated not in this release. It was released earlier. The reason is that Microsoft Passport, which is essentially the same thing, has been in existence for some time. So if you go and do the latest diff, you may not see the changes for this, but there is one new section added in the document for key trust, and I have mentioned that here at the in the close to the bottom of the slide. For the certificate trust, there is no requirement needed, change is needed, since a smart card has been in existence for quite some time now, and we support a smart card authentication, which basically does the certificate authentication. For the key trust, Windows Server 2016 is required. Okay, so the older domain controller will not have any concept of just dealing with the public key instead of the certificate. Okay, a section for key trust is added in this document, as I mentioned. User sends public key in the AS request, and the server matches that with one in user object, which is stored in the attribute MSDS key material. Okay. All right. So that's my presentation. I think I finished it earlier than I was supposed to. I don't know what the time is. What's the time? Anyone?
On time.
I'm right on time. Okay.
Are there more questions? I have a comment since you said I could answer something.
I'm sorry.
No. So in Cam's talk earlier, he did talk about the 3 different types of TPMs: the hardware, the firmware, and the virtual. I can't answer the question, but I can say Cam will be at the event tonight. He said he would be there, and so you might want to ask him. In terms of people from the Windows Hello team or the ADFS team, actually, I don't know whether they accepted the invitation to come to dinner tonight. They're invited, but if you have questions, we might be able to connect you with a PM on that team to ask questions. So
Yeah, well, in the case of TPM, there is one more comment I would like to make. The TPM version 2 is recommended much faster than the TPM version 1.2, which is
Yeah.
very finicky. And you can control that by group policy. If it is TPM version 1.2, do not use Windows Hello.
Yeah.
Thank you for this presentation, Obed. It really helped a lot to
All right.
understand the protocols used with Windows Hello. I would like to make a comment and also a question,
Okay.
ask a question. I think Windows Hello was to log in a more secure way. But one of the value of it was a single sign-on. Can you please elaborate a little bit on the single sign-on part?
So as far as the single sign-on is concerned, we have single sign-on for a long time. The way single sign-on works in our corporate environment is that we use Kerberos authentication, right? The first thing that happens in Kerberos authentication is that you send an authentication server request to the KDC, right? KDC issues you something called TGT, ticket granting ticket. That is cached on your computer, not your password. So after that, whatever resources I want to access, I can use that TGT to get the ticket for those resources. That process is called TGS, by the way. So in this case, we are replacing password with asymmetric keys. But at the end of the day, those asymmetric keys are used to get a TGT. And then that TGT is used to do, as usual. Most of the time, the problem happens is that we, as users, do not like to remember too many passwords, right? So we tend to have the same password for all our websites everywhere. And if somebody knows one of our passwords, we are, doomed because they can use to log in anywhere. The other problem is that password is not tied to a device. It is only tied to a person. So wherever that you use that password, it will work. So you just need to know the password. In this case, what do you have is the device. If you say Windows Hello on this computer and then you take another computer and do Windows Hello, your private key on those two computers are separate. They're different. So even if you get hold of the private key somehow, which is very difficult since it stays on the TPM, you also need the physical access. Hackers generally are not the people who are living in your home. They already know your password and everything. They already have access to your resources. They generally sitting somewhere, maybe across the world, and doing all sorts of attacks. But so I think did I answer your question about the single sign-on in the way of Kerberos?
Yes, in the corporate environment, I was expecting a little bit more on the Open Connect side.
Oh, okay.
Because OpenID, OpenID, because I think that's one of the big scenario.
That scenario comes into play when
with
we
Azure,
are
yes.
in the Azure. Yeah. So for example, you can also, even if you're not in the corporate environment, you use Microsoft account, right? When you use Microsoft account, you can also use Windows. You can also configure Windows Hello. And in that scenario, once you do this all business of saving your public key in the Azure Active Directory, when the time for login comes, instead of Kerberos, you use Open Connect ID. So a token is issued to your device, and then I was actually reading about it, and I think the token in this case is called refresh token, but my memory is probably not serving me right. and then you can use that token to request other services, which works similar to TGT that we have in the Kerberos world. All right, so any other question?